Hello, in this video we're going to show that when you have two vectors and you take the magnitude of u times the magnitude of v times the sine of the angle between them, then that is the same as the magnitude of the cross product, right? Now geometrically what this would look like if you have two vectors right here. Let's say we have vectors as such, and this is vector u and this is vector v. And then if I draw a perpendicular line right here, then and this is angle theta, this height right here would be the height of this triangle that's created right here would be magnitude v sine of theta, right? Good. And then you can see if I make the parallelogram created by these two right here, this parallelogram, the area of a parallelogram, if you were to find that area, would be the base times the height, right? So in the base, the length of the base here of this parallelogram with vector u is magnitude u, and then I multiply it by its height, which is magnitude v sine of theta, right? So it's an interesting concept that when you take the magnitude of the cross product of two vectors, you are finding the area of the parallelogram. And you can also find the area of the triangle by just halving it, right? That's created by these two, right? So the area of the triangle that's created by two vectors is 1/2 magnitude u, magnitude v sine of theta. Good? So that's what we're going to show. So we've connected how these two, how this is what this representation is, but now we're going to take this guy and show that it's actually equal to this. So this one will be a long one, so you've been warned. So here we go. First thing we're going to do is let's assign what u is equal to. So if I go vector u, we're going to call that vector a, b, c, and vector v we're going to call x, y, z, right? Good. And then the first thing we're going to look at a lot of different things here to make this all fit to work with this. The first thing we're going to look at is the magnitude of the cross product, right, squared, right? Now, if we were to take the magnitude, there would be a square root inside of this to find the magnitude, but it's going to be squared out, so that won't be there. But so what is the but it would be squaring the components of everything that's in here, right? And the way that I found the x coordinate that I'm going to square is I put my hand over this and I go b times z, right? So I'm going to have bz minus bz cy. That's going to be squared. And then the y coordinate that I have to square would be found by putting my hand over here. I could go minus this times this, but I'll go cx. So I'll go cx minus cx az, and then I'll have to square that. And then the last one, put my hand over this, and I go the proper way, ay minus bx. And then I square it, right? So the first thing that we have right here, this would, I'll use my rule here, so that's b squared z squared minus 2, try to keep everything in alphabetical order, 2 b c y z, and then plus c squared y squared. And now I'm going to stack, that's a little bit of messy, c squared, right? And I'm going to stack these instead of writing long, since it's so long. This squared would be equal to c squared x squared, and then I'll have minus 2 acxz plus a squared z squared, right? And then the last one, I'm going to have a squared y squared minus 2 abxy plus b squared plus times x squared, right? This is supposed to be a z. I want to make sure I can, I'm going to make sure I can see this. I don't want to make any mistakes. So this is supposed to be z squared. There you go. Good. And then the next thing we're going to look at now, so that's the one thing we're going to look at. Let's use a different color. Let's see. Let's go with this. So the next thing I'm going to look for is u dot product b, and then I'm going to square it, right? Square it. So let's think. What is u dot product b? And then I will square it. Well, u dot product b would just be a times x plus b times y times b times c, right? So it'd be ax plus by plus cz. But since we're squaring it times itself, it would be multiplied by another one. So ax plus by plus cz. And then I'm going to distribute property this through, right? So let's get some more room. So this times this is going to be a squared x squared. You might start noticing what's happening up here. And then this, so that's that times that. This times this would be abxy. And then acxz. Good. So I took this guy times everything here. Now it's this time. Now by times this, it would be abxy, abxy. So I can I'll stack it right where it's like terms were, right? Then I'll go by times by. Well, that's b squared y squared. I'll put it here. You can see where. Then the next one is bc yz, nothing here, so I'll go bcyz, and then the last one is the cz, and this is acxz. That would line up right here, so acxz, and then bcyz, that's right here, right? bcyz, good. And then the last one is, I'll just write it over here because they're the same components, so c squared, z squared, right? And then what do I get? Looks like I'm going to get that u dot product b squared was going to be a squared x squared plus b squared y squared, and then c squared z squared, these add up to plus 2 abxy plus 2 acxz plus 2 bcyz. Good. Now we're going to go up here and take what we found, this guy. If we look at these two right here, what these two look like, right? So can I get them on the same screen? If you notice, we have some terms that could possibly cancel out. So what we're going to do is we're going to take this guy right here, the magnitude of the cross product squared, and add it to this guy and see what we get. So let's go ahead. So we're going to take the magnitude of u cross product b, right, and square it, and we're going to add the u dot product b, square it, and see what this comes out to be, right? Now if you notice what happens first, right, it's right here. Well, 2abxy, well, if you add them together, 2abxy cancels out with that one, 2acxz cancels out with that one, and bcyz cancels out with this one, right? Good. And what are we going to be left with? What we're going to be left with is, let's look at the a squared x squared. So I'm going to have a squared x squared, and then I'm going to have, so that's a squared, where is that? A squared x squared. Where's the other? A squared y squared plus a squared y squared. That's right there. And then a squared, where's the a squared z squared? Right here, a squared z squared. So a squared z squared, right? Then we're going to also have the b squareds, right? We have b squared x squared. So b squared x squared. We're basically going to have b squared y squared plus b squared z squared. And then we're going to have c squared x squared plus c squared y squared plus c squared z squared. And, right, so b squared y squared, b squared z squared, c squared x squared, y squared, and z squared. They all come out to right here. Now, the trick is to look at this guy right here. Now, if you think about it, this right here, what is that equal to? That is going to be equal to, this guy right here is going to be the magnitude u times the magnitude b all squared, right? Why? What's the magnitude of u? That would, if u is the component ABC, then it's going to be the square root of a squared b squared plus b squared plus c squared. And the magnitude of v has components x, y, z, so that's x squared plus y squared plus z squared. But those are just the magnitudes times, we're squaring this, right? And this would, if this all squared, these square roots get lost, and we'd end up taking a squared plus b squared plus c squared, and we'd multiply it times x squared plus y squared plus z squared. And if you notice, this times this, that component, right? This times this, that component. This times this, that component. Then b times x, b squared times x squared, b squared times y squared, b squared times c squared, and so on. You can see, you can check right here, this is the same thing. So, finally, we're almost there now. So what do we have now? We know that this guy here is equal to this, so I know the magnitude of u cross product v squared plus u dot product v squared is equal to the square of the magnitudes of the two vectors, right? Good. And then, but what? Well, then I can. Well, first thing is I can solve for this, right? So I got magnitude u cross product v squared, right? This guy right here would be magnitude u squared times magnitude v squared, right? Minus u dot product v all squared. But what isn't u dot product v equal to magnitude u magnitude v times the cosine of theta? So if I take this and I square that, I'm going to have magnitude u squared magnitude v squared minus magnitude u squared magnitude v squared times the cosine squared of theta, right? Almost there. And then look, I have a common factor of magnitude u squared magnitude v squared 1 minus the cosine squared of theta, right? But what is the 1 minus the cosine squared of theta equal to? That's equal to the sine squared. This is equal to the sine squared. So I got magnitude u squared plus magnitude v squared times the sine squared of theta. And this is equal to the magnitude of u cross product v all squared. And then if I take the square root, finally I get what we've intended to show from the beginning, is that the magnitude of u cross product v is equal to magnitude u magnitude v times the sine of theta. And that's what we wanted to show. So, and we did. So that was a pretty long one, but we could see this what happens. And what does that magnitude do? We've showed what we wanted to. And if you remember what we talked about, this magnitude and this gives you the area of a parallelogram in space given two vectors, right? If this is u and this is v, this area that goes inside of here, the area of this parallelogram is the magnitude of the cross product of two vectors, and that gives you the area. And then if you want the triangle, it's half, like we said earlier. And there you go. Thanks, guys.